Hello everyone, myself Dr. Rupashri Kadu, working as an assistant professor in Department of Chemistry in Arts, Science and Commerce College, Mokhada, District Palghar. In this conference, I am presenting a paper entitled Efficiency Alkylation Employing Green Reagent to Afford Dialkyl Fluorine. This slide showing the importance of the dialkyl fluorine molecules. These dialkyl fluorine molecules are very much important monomers for synthesis of the polymers, and such polymers have a grateful applications in light emitting diodes, solar cells as well as transistors. So these are the few examples of the dialkyl fluorine molecules. These are the applications of the light emitting polymers. These light emitting polymers are highly applicable in the cell phones, shoe, indicators, car headlights and the road lights. This is a previous methods of alkylation of fluorine. This is a reported method in which the 2,7-dibromofluorine get converted into the alkyl substituted fluorine molecule, and this previous reported method having a few drawbacks, which are means it requires a corrosive catalyst like KOH or NaOH. Also, it requires the additives like phase transfer catalyst. It requires hazardous solvents like DMSO. Also, it having very toxic solvent like benzene are used, and it has a high reaction temperature and the longer reaction time. Hence, we have decided to develop a new method for the synthesis of these alkylated fluorine molecules, and which will require very mild reaction condition, which will work without any catalyst or additives, which will work in environmental friendly solvents, and which having a very rapid speed and gives a high yield. So now this slide showing our developed method for the synthesis of the dialkyl fluorine, in which the 2,7-dibromofluorine get converted into the alkyl substituted 2,7-dibromofluorine by using simple alkyl halides and the ionic liquids. In this reaction, the ionic liquids solution act as a catalyst as well as solvents. Hence, there is no any need for the additional catalyst or additives and the solvents. These are the various materials were used for the synthesis of these particular monomers, in which we required 2,7-dibromofluorine, alkyl halides and the ionic liquid like 1-ethyl 3-methyl imidazolium hydroxide solutions. This is a procedure for alkylation of fluorines, in which first 2,7-dibromofluorine and ionic liquid solution were added and mixed into a round bottom flask. Then alkyl bromide was added to our mixture and heated at about 60 degrees Celsius continuously for the 2 hours, and by monitoring the TLC, the completion of the reaction, after completion of the reaction mixture was cooled to room temperature and extracted with the chloroform. This extracted chloroform organic layer was washed several times with water and dried over the anhydrous sodium sulfate, and then the solvent was removed to get the desired product, which having a 99% yield. Now, this slide showing the characterization of the synthesized monomer. Like this is a H1 NMR spectrum of the 2,7-dibromo 9,9-diethyl fluorine, and this is another slide which showing a NMR spectrum of 2,7-dibromo 9,9-dipropyl fluorine molecule. Now, significant feature of the developed method is it is completely aqueous phase synthesis. The ionic liquid solution act as a catalyst as well as solvent, hence there is no any need for the additional catalyst and additives. It is commercially available ionic liquid solution. The reaction temperature is 60 degrees Celsius. Then the short reaction time, which gives the high yield of the product, and more importantly, the ionic liquid solution is recycled and reused up to the 5 cycles. The application and the future scope of this is it provides the improved method of the alkylation of fluorines under very mild reaction condition. This method may find application in polymer chemistry for the preparation of a different alkyl substituted fluorines desirable for the polymer synthesis. The future work will focus on the application of this alkylation method in other systems like aniline and phenols. As in the conclusions, we have demonstrated the ionic liquid as an efficient reaction system for alkylation of fluorine without using additional catalyst, additives and solvents under mild reaction condition. These are my few key references. Thank you for your attention and thank you for giving me chance for presenting my paper. Thank you very much.